Hello, Programming 12. We're going to be beginning a new unit on making sketches in 3 dimensions. Previously, all of our sketches have been in the 2 dimensions of X and Y, and so now we'll be adding in a Z coordinate, and I think most of you are familiar with this type of project because you've probably played Minecraft or any first-person shooter, any video game involving 3 dimensions. So I won't go into too much detail in this first lesson on just all the different aspects, but I will definitely we'll start with some examples of how we can turn a processing sketch into 3D, and then we'll start getting more into the math as we go. I might save some of that as well for just the in-person lessons, because having a whiteboard in front of us will be very helpful. I'll try to do my best for some of that in these videos as well. So let's get started. First off, if we're going to make a 3-dimensional sketch, a lot of the 2-dimensional stuff is still true. So for example, we're still going to have void setup and void draw. That doesn't change at all. And we're still going to make a size for our graphics window that we're going to create. So I'll make maybe an 800 by 800 window. But we do have to include a 3-dimensional rendering engine. So normally we use either nothing, that's the default engine. Sometimes we've used FX2D to kick it up a notch and have a more stronger rendering. Well, notice the 2D stood for 2 dimensions. There's also P2D, which is again another 2-dimensional rendering engine. But it turns out there's also P3D, which is what turns our sketch into a 3-dimensional sketch. Basically supporting things like 3-dimensional transformations, having a Z coordinates in addition to X and Y coordinates, and various other features that would be pretty useless in 2D, but are extremely important in 3D. So that's the first step, is just turning on the rendering engine to the P3D one. And then we can kind of do stuff. If you want to kind of check some stuff out, we can do, for example, pardon me, we gotta get more sleep at night. Box is, for example, a name of a function we can call. Box, we can say, it's basically like rect, right? A rect creates a rectangle, so box creates a rectangular prism, a shape with a length, a width, and a height. We can specify that information, but we'll just start off with a good old-fashioned, straightforward box. It's maybe 100 by 100 by 100. So these are the dimensions. It goes length, width, and I think depth is technically the name of what they use. So maybe, I'm not sure if length and width are necessarily the best names for these. But you can double check the reference page just to double check what it looks like. You can always go to any find in reference. You can just kind of highlight something and you can search it and you can take a look at the reference page and see what's going on here. So let's see, width, height, and depth is actually how they describe that. So let's put that back. Width, height, and depth are, I guess, how they describe that. Okay, that seems good. And you notice there's no coordinates. This is just the size. You actually don't, in 3 dimensions, you don't specify where the shape will go inside of the shape function. You're going to have to rely on things like translate for that. Otherwise, it won't work too well. So, for example, I can do a translate, and translate just kind of shifts where the origin is. So note that the box, or whatever shape you draw in 3 dimensions, always gets drawn at 0, 0. So you just have to first move 0, 0 to your desired place. Then go to width, maybe divided by 2, height divided by 2, and 0. So this means, width means, this is still our X and our Y, and this is our Z coordinate. So a X and Y coordinate still mean the exact same thing as it did before. X is across the screen, Y is down the screen, and the Z coordinate will sort of be coming towards or away from the screen. So a Z of 0 will basically be where it already is by default. That's sort of the default place for things to be. But we can increase this to bring it closer to the screen and decrease it to make it go away from the screen. You can increase it so much that it goes beyond the viewing sort of camera and goes behind the camera, because your world can actually be quite large. So this is going to be a particularly difficult challenge as we're playing around with these things. So we're not going to get into that too much in this video. We're just going to basically move things around kind of in these one set of dimensions. So I'm going to run this and just see, what do we get? What does this thing look like? So we'll go ahead and run it, and oh, it's a box. Yay. It just looks like I did Rect. It doesn't look too three-dimensional at all. So no problem, let's get this looking a little bit fancier. Right now, there's a fill in this box. So it is a cube, but its faces are all white, and we're just seeing that one face, that front face. So what we can say is no fill. We could turn that fill off. And by the way, all of our fill function and everything, they work just fine. No different than how stroke, fill, stroke weight, those all work exactly the same as they did in 2D. So I run this, we get no fill. You can kind of see a bit more of the two dimensions. Can you see that? You kind of see that box kind of going inward, like, as if you can sort of see some depth to it. But honestly, this won't make much sense until we can start manipulating and rotating this little guy around. So what I'm going to do is add in some rotation features, and you can learn about rotating things as well. So I am going to be showing you, you're familiar with rotate. You've seen that before. We've used that. But in 3 dimensions, there's no rotate. You have to choose an axis to rotate around. So for example, rotate X. It will rotate your whatever's between your push and pop matrix, which I'm not using yet, but we will use. It rotates it around the X-axis. So you could think of the X-axis as sort of being, this is a random pencil I just discovered here. It's like around here, right? So it's going to go around the X-axis. So if this was, I don't know, I'm looking for random things I have on my table here. I don't know if this is our box here. Then if we're rotating around the X-axis, it's going to kind of go around this way. I don't know if you can even see this. I hope this is making any sense. This is how it's going to rotate around. We also have rotate Y. This needs some parameters, so I have to come back to this. Rotate Y, well, the Y-axis is up and down, right? So it'll rotate around the Y-axis. So it rotates this way. There's also a rotate Z. And rotate Z, the Z-axis is coming straight out of the screen. So it'll sort of go around this way, if that makes sense. Kind of the do a barrel roll style. Oh, I didn't put a Z in there. Sorry. Rotate Z. That's what I meant to say. It'll rotate it kind of this way. Although this can all get kind of changed because our camera will eventually move around. So the Z-axis, X-axis, Y-axis, they won't change, but our perspective will. So that's going to get a little bit complicated. But for now, I think that's a reasonable definition of what these rotate functions do. And again, just to keep things simple, let's ignore rotate Z. We won't worry about rotating in the Z-axis. We'll just rotate X around sort of this way and around this way. So I'm going to make a couple of variables to make this work. I guess I'll call them floats. We could say rotate, X rotation and Y rotation, rot X and rot Y. Ooh, those sound kind of gross. But whatever, it's fine. And I can rotate by that. I can say rotate to whatever X is and rotate to whatever Y, rot Y is. These are just angles. I gotta admit that they're not in degrees, they're in radians. So I am ever fighting the battle. There's 0, I haven't rotated. I'm ever fighting the battle of should I teach you radians? And I normally would be like, I should teach you radians, but because we have a condensed year, I'm not 100% sure it's worthwhile. But hey, guess what? There's a radians function that converts. So let's say I wanted 90 degrees. I can say radians 90, and that works out just fine. So let's rotate by maybe 45 degrees around the X and around the Y axis. And then we can sort of see what we've done here a bit. Type it in 45. There we go. So 45 degrees. So imagine we rotate a cube 45 degrees this way and 45 degrees that way. What do we end up getting? Well, now you can see, let's run it. Now you can see our cube a little bit better. You kind of have to stretch your imagination to understand sort of where the front face is on that. It kind of looks like, if you get the faces wrong, you can end up seeing it sort of like it's not actually a cube. But that's sort of gets a little more intuitive if we can sort of manipulate it on the screen. You know what I mean? If we can like click it and drag it around, it'll feel so much more understandable and solid. You know, like it'll feel like it's 3D. So let's add that in. I'm going to give you a nice little function here. Actually, we'll just put in the mouse release function. Void mouse release. No, sorry. Void. Let's do void mouse dragged. Yeah, mouse dragged. So this will basically fire whenever we're clicking and moving the mouse. So that will be an excellent place to be able to click and drag and manipulate things. So what I'm going to do is I'm going to do something like this. So when I'm clicking and dragging, I'm going to set the rotation variable to whatever it was plus, and then I'm going to take the difference of the previous mouse's coordinate. And I'm going to use mouse Y for that, and the current mouse's Y coordinates. So you might wonder, why mouse Y? Why would Y change the rotation around the X-axis? But remember, the X-axis, we're rotating around it, right? We want to spin around this way, so it makes sense to click and drag it to go up and down to spin it around the X-axis. So that's why we're doing that. Now this difference between where the mouse was and where the mouse is, that will actually be pretty big compared to what radians are. So I'm going to just multiply this by like some small number to make sure that I don't over-rotate it. So let's just run this and see what happens. I'm going to go run, and we'll see if we can see it. And if I click and drag, oh, sorry, we should. I've made a huge mistake. We should probably get some background going there. Let's put in background 255. Yes, try again. Sorry. Here we go. So now if I click and drag, you can sort of see this. You see the rectangle kind of rotating around, or cube, I should say. Yeah, that looks pretty good, right? Looks good. So you can see it's sort of like impaled along here, like it's like a skewer is going through it. And as I click up and down, it's kind of rotating around that axis. So hopefully that illustrates better sort of what rotate X does. Rotates around that central sort of horizontal axis. And why we're using P mouse Y and mouse Y. I'm going to click up and down to spin that around. So now we'll do the same thing with rotation Y, whatever that is. But this time it'll be mouse X minus mouse X, because we're going to spin it this way around the vertical Y-axis. So we want to spin it around there. So we want to click left and right to make it move. Now, if I actually know I should put it in like this, but I'm just going to put it without the negative sign to start with, just to like show you what it looks like, because it's not obvious why that negative sign will be there. But once you see it, you'll be like, oh, that's why we need the negative. So I'm going to run that, and you'll see if I click now left and right, it's sort of working. If I sort of rotate it around, it'll be a little bit backwards though. Can you see how I'm like going to the left? No, sorry. I'm going to the right, but it's spinning the opposite direction. That's kind of annoying. It actually makes sense that that's happening in terms of like the rotation. It's like, you know, the y or so the x, yeah, the x coordinates increasing, so the angle will increase, but that's not how it actually plays out visually. So I'm going to put in the negative sign just to flip that around. And then we'll be able to like now rotate it in nice, gentle ways. So that looks pretty good, right? We can now see our cube moving it around nicely, and that's pretty good. I think it helps to increase things like the stroke weight and that kind of stuff. So if you are willing to do this, I don't see why you wouldn't be. I'll go put in a little bit more visual detail. And this is just a blast from the past. It's just old-fashioned stuff like stroke weight. You know stroke weight. Stroke weight's just, how thick is the stroke? I'll put in a stroke of black. It already is black, but I'll just double check that it's black. So if we run that, we'll see a nice darker stroke that'll make things easier to sort of visualize. You can put in a fill there so that the depth and seeing those back walls don't confuse you. I think that's a worthwhile thing to do. So I'm going to get rid of no fill. And although it's kind of cool, and you don't have to not use no fill, it's fine, but I'm just going to put in a fill, maybe like red or something, just so I can see a little bit what's happening better. Red might be a little bit too intense. Oh, it's pretty bright. And there we go. Now we can really see what's going on here. So I can manipulate this and move it around and see it in 3 dimensions. So that's nice. I guess I could increase the size as well. Maybe that'll be sort of the last thing I do. Before pausing the video and moving on to another one. So here we go. There we go. That's a little bit bigger. And now really nice and able to see this as sort of a viewing thing. Looks good. Looks good. All right, so we've created ourselves a simple box in 3 dimensions that we can maneuver with the mouse, clicking and dragging it and moving it around. Looks pretty good. That was sort of the first step. The second step we're going to explore a little bit more in the next video, which will be taking a look at spheres, just out of interest's sake, that you can make a sphere. And then we're going to take a look at, this is a lot of stuff. We're just kind of, we got all this stuff. It's kind of gross. I like to turn that into a function that we can just call. That'll be sort of our third step. Later on after that, I think we'll still have time on the first day of this unit. We'll also take a look at texturing a box. So instead of like it just being like a fill, we can put pictures on the sides of it. Anything really. You can even put animated GIFs on there. You can have like a cube of GIFs. They move around as a different sort of GIF or whatever each time. It's kind of a wild idea. But we'll see how to put textures on things. Unfortunately, that gets really complicated. So, you know, we'll do as much as we can. Hopefully that goes well. So I hope that you are also doing this, and I hope you've also created this sketch. Feel free to experiment and add additional fun stuff to it. You know, you could, you know, just if the whim strikes you, you know, you have a bit of time as we're sort of experimenting right now to feel free to go and try, for example, changing the translate coordinates with the keys or something like that, and you can move your move your cube around with the keys. That kind of stuff could be fun. All right, so I'm going to stop the video there. Thanks so much. I hope you're having fun with 3 dimensions, and we'll check you out in the next video where we'll do a sphere and maybe some just like 2D stuff within 3D just to see what that's all about. Okay, thanks for programming 12.